We have given function f which has three parts, and we have to evaluate each of following limits if exist. So let's do the first limit. We have limit of fx as x approaches 2 from the right side. Let's see which part of our function is defined for x greater than 2, because we have x approaches 2 from the right side. This is for negative 2 less than or equal. This is for x belongs to interval from negative 2 to 2. And the third part is for x greater than 2. So it means for limit of f of x as x approaches 2 from the right side, we will check our third part of our function. So we have to calculate limit as x approaches 2 from the right of x minus 2. Because we have subtraction here, we can just replace x by 2, so we will have 2 minus 2. This is equal 0. So we have first limit. Next, we have to find limit as x approaches 2 from the left side, f of x. X approaches 2 from the left side, so it means value must be less than 2. We have value less than 2 for this part of our function. So we will replace f of x by 4 minus x squared as x approaches 2 from left. So this is equal, because we have power and subtraction, we can replace x by 2, so it will be 4 minus 2 to second power. This is equal 4 minus 4, so this is equal 0. So we have second limit. Now we have to find limit as x approaches 0. So let me write this. Limit as x approaches 0, f of x. First, we have to find which formula belongs for this x. X approaches 0. So 0 belongs to this part, because 0 is between negative 2 and 2. So I will replace our function f by 4 minus x squared. So we have to calculate limit as x approaches 0 of 4 minus x squared. So now, because I have subtraction and power, I can replace x by 0, so it will be 4 minus 0 to square, so this is 4. We have third limit. Now we have to find limit as x approaches negative 2 from right. So let me write this. We have limit as x approaches negative 2 from right of f of x. So first we have to find which formula belongs for this x. X approaches negative 2 from the right side, so the value must be greater than negative 2. So we have to use this formula. So we can just put for f of x limit as x approaches negative 2 from right of 4 minus x squared. So this is equal, because again I have subtraction, the power I can replace x by negative 2, so we have 4 minus negative 2 to second power. This is equal 4 minus negative 2 second power is 4. This is equal 0. Now we have to find the limit as x approaches negative 2 from left. So let me write this. We have limit as x approaches negative 2 from left of f of x. This is equal Now we have to check which formula of our function represent x approaches -2 from left. It means value less than 2. Value less than 2 we have for -x. This is formula for x less than -2. So we will replace our function f by -x. So we have limit as x approaches -2 from left of -x. So I will replace x by -2. So we have negative sign, we just copy, and we have -2. This is equal, negative and negative is positive, so we have value 2. Now we have to calculate limit as x approaches -2 of f of x. Let me write this. Limit as x approaches -2 of f of x. We calculate before limit as x approaches -2 from right and x approaches -2 from left, f of x. And we see these limits are different. We have 0 and 2. It means the limit as x approaches -2 of f of x does not exist. Why? One more times. Because limit as x approaches -2 from right, f of x, is different than limit as x approaches -2 from left, f of x. That's why the limit as x approaches -2 of f of x does not exist. I just copy our f function. Now we have to just sketch the graph of this function. Our function f has 3 parts. For x less than or equals -2, because we have linear function, will be straight line. And this line is decreasing because we have negative coefficient. The second part for x greater than -2 and less than 2, so it means x belongs to interval from -2 to 2. We have to draw piece of parabola because we have quadratic function, and the parabola will be up and down because the coefficient before x squared is negative. For the third part, for x greater than 2, we have to draw against straight line because we have linear function and the coefficient before x is positive, so the line will increase. So, like before, I will divide our function f to 3 parts. We have f1 of x. For x less than or equals -2, we have formula -x. This is for x less than or equals -2. The second part will be 4 minus x squared for x belongs to interval from -2 to 2. And the third part will be x minus 2 for x greater than 2. So to draw the graph, we need at least 3 points. So let me choose x. X must be less than or equals -2. So I can choose -2, -3, and -4. The value f1 of x is equal -x. So now I will replace x by -2. So negative sign I will copy and I have -2 in parentheses. Negative and negative is +2. We have negative in parentheses -3. Negative and negative give us +3. The same here. We have -4 in parentheses. Negative and negative give us +4. So we have 3 points, -2, 2, -3, 3, and -4, 4. Now we have to choose x from interval negative 2 to 2 is open interval, but like before I have to check how this function we have at the end this interval. So I will choose negative 2, 0 and 2 is my x, and the second row is for value f of x equals 4 minus x squared. So we have to replace x first by negative 2. It will be 4, I will copy, minus negative 2 to second power. So we have negative 2 to second power will be 4. 4 minus 4 is 0. Now I have to replace x by 0, so will be 4 minus 0 to second power. This is equal 4. And now I will replace x by 2. So will be 4 minus 2 to second power. This is equal 0. So we have 3 points, negative 2, 0, 0, 4, and 2, 0. And the third part, x belongs to interval from 2 to positive infinity. And like before, I have to check what happened when x equals 2. Value greater than 2 will be 3, 4. This is my x. And value f of x for x minus 2. Now I will replace x by 2. 2 minus 2, this is equal 0. 3 minus 2, this is equal 1. And 4 minus 2, this is equal 2. So we have 3 points, 2, 0, 3, 1, and 4, 2. Now we have to draw xy plane. We have to choose the unit. First point we have negative 2, 2, negative 2 and value 2. So will be here, and negative 2 belongs to our function because x is less than or equals negative 2. Next, we will have negative 3, 3. Our second point, this was first negative 2, 2, negative 3, 3, and third point is negative 4, value 4. This is connect. Where for third point, negative 4, 4. Now we can connect these points because our function was a linear function. The graph is straight line, and the domain for this part was x is less than or equals negative 2. Next we have points negative 2, 0, negative 2, 0, and because we have open intervals, so negative 2 and 2 are not included. So I will draw the circle for negative 2. This is negative 2, 0. The second point is 0, 4. And the third is 2, 0. And like before, I will draw the circle. Our second function is 4 minus x squared. So the graph will be parabola, open, down, because we have negative coefficient before x squared. So, and this parabola is symmetrical about y-axis. We have to draw only this part because the domain for this function is interval from negative 2 to 2. Next, we have to find points 2, 0, 2, 0, and 2 is not included because we have domain x is greater than 2. Next we have 3, 1, 3 value 1, 3, 1, and 4, 2. For 2. Again, because we have x minus 2 is linear function and the graph for linear function is straight line, coefficient before x is positive, so the line is increasing. So let me connect this. It's going to positive infinity and start at point 2 because we have function for x greater than 2. So this is my f function.